F3x belongs to the second quadrant. Because the tension, which is the F3, the tension is on the second quadrant. Components of F3 on the second quadrant are X component and Y component. On the second quadrant, X is negative, Y is positive on the second quadrant. Therefore, this one, the X component, this is negative. F3 refers to the tension. Tension. X there is negative X component. You have here negative, and therefore this becomes now negative. Okay, negative, and this becomes negative. Okay, so review the previous one because I erased already to indicate the negative sign of the X component on the second quadrant. Okay, negative X on the second quadrant. Third quadrant, negative X. Fourth quadrant, positive. First quadrant, first, second, third, 1, 2, 3, fourth, 1, the letter B, Roman numeral. Okay, so there you are. So what happens now? You will have F2 minus F3 sine theta equals 0. I have no more here. This one. Maybe this one. Okay. F2, this one. 1 times 2. F2. 0 times F1. 0. So you have here 0. 0. 0. Plus 1 times F2. F2. Minus F3. F3 sine theta equals 0. And therefore, our F2 equals F3 sine theta. Okay? Or, theta is a known, right? F3 is a known. Okay. This one, this W2 is our FP, the pulling force. Our F3 is the tension, sine theta. Theta is a known, tension is a known, we cannot solve the problem. So we need to have the next component, the Y components. Okay. I'm going to erase, I'm going to erase this one, I will erase this, I will erase this. So that I have space. I'm going to erase this. Erase. Okay. I will proceed here because having this one, remember this one? This one? The solution here. How about this one? This one we solve here. Summation of Fy equals 0. Summation of Fy is F1y plus F2y plus F3y equals 0. Okay? Similar here. Summation. Here. Okay. Y components. Here. You will have here F1 sine Y component 270 degrees plus F2 sine 0. Plus F3Y, our F3Y is here. F3Y, 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 F3Y. I discussed this one with you. What is this F3Y? Plus F3Y, you have F3 cosine theta. Now, if y component, okay, y component here, angle taken from the x-axis, use sine. Y component, angle taken from the x-axis, sine. Y cosine. Cosine here because the angle is taken from the y-axis, not the x-axis anymore. 270 taken from the x-axis. 0 taken from the x-axis. Y component there is sine. Here, angle theta is taken from the y-axis. The y component here, f sub 3y, taken from the y-axis. X-axis, y-axis. Theta, theta. Cosine, theta. The theta taken from the y-axis. I already discussed this. So, here, F1, cosine, sine 270 degrees. What is sine 270 degrees? Sine 270 degrees, what is that? I will answer my question. Negative 1. So, this one equals negative 1. And so, you will have here F1 times negative 1 plus F2 times sine 0. What is sine 0? Sine 0. I will answer my question. Sine of 0 angle is 0. So this is 0. So here times 0 plus F3. F3, the y component here is positive, ba? Positive. Y component is positive. So you have F3 cosine theta. Theta is taken from the y-axis. So cosine theta, we do not know. So, F1 times negative 1 is negative F1. Plus, F2 times 0 is 0. Plus, F3 cosine theta equals 0. And therefore, our F3 cosine theta, our F3 cosine theta equals positive F1. By transposition here. Review ha. When you look at this video, review. Backward or reverse video or backward the video. There is the button there. Backward. Repeat. Backward again. Until you can understand. Okay. Well, I have this. Now, here, I'm going to erase this one, ha? Erase this one already. I'm going to erase this. Erase already. Our F3, remember our F3 is tension. Cosine theta, our F1 is our weight. F1 our weight, F1 weight. F3 is tension. Tension equals F3. Oh. Tension equals F3. Tension. So this one is F3 equals tension. F1 equals the weight. Okay. Now, tension unknown, theta unknown, weight is known. Okay, weight is known, right? What is the weight here? Weight, tension, equals the weight, tension cosine theta equals the weight, weight equals mg, and m is what is m? The mass. M, the mass is 2,000 kilograms. Okay, 2,000 kilograms times g. I will use 9.81. Or you can use 9.8. It does not matter. Correctly solve. Whatever the value, 9.81, 9.8. Correct. But I am introducing to you 9.8 because this is the usual value in most of the physics books. Okay? But because we're using the textbook here, we will adapt that value 9.81. Sir, I will maintain 9.8. So be it. No problem. No problem. Daily wrong, sir? Not wrong? Not wrong. So long as the solution is correctly solved. Whatever your value in G, either 9.8 or 9.81, do not matter to me. Okay? So, meters per second square. So, the answer here, calculator, I will use the calculator, 2,000 times 9.81 equals 19,620. Okay. The answer here, T cosine theta equals 19,620. 620 kilogram meter per second squared. Kilogram meter per second squared is newtons. So this one. Now, how about here? So we cannot solve further. We have this one. We have this. Remember, we have this, huh? We have this. FP. You look at this. This one. This one. This one. This one. This one. This one. You have that. Where will I write it? I will write here. I will write here. Okay. I will write it. Remember here, I will rewrite this, Rewrite this. Rewrite. FP equals T sine theta. Okay? Our FP, pulling force, FP, pulling force, FP, 1,800 newtons equals T sine theta. You get that? Okay. 1,800 given in the problem, 1,800. Okay. And so therefore, we can, from here, we have tension is equal to 19,620 newtons divided by cosine theta. That's the tension. Okay. There. Now. And so this one, therefore, okay, you will have here, the tension here is this one. Okay? I hope. So you have 1,800 newtons is equal to the tension. This is the tension is 19,620 over cosine theta. This is the tension, tension, 19,620 newtons over cosine theta. Tension, 19,620 cosine theta times sine theta. Sin theta. Tension! Okay. So, I hope you can just follow, ha? From here, I'm going to erase. I'm going to erase this one, ha? I'm going to erase this, ha? Erase. 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 I'm going to erase. Okay. Erase. Okay. And so, we will have here. You look, ha? You look. You have 1,800 newtons over 19,620 newtons, because this one is newtons, okay, is equal to sin theta over cosine theta. Can you follow? Can you follow? Cross multiply 1,800 newtons. This one cross multiply there. By cross multiplication, what remains is sin theta over cosine theta. Where is the 19,620? Cross multiply here. Cross multiply here. Cross multiplication. And this is equal to sin theta over cosine theta. This is the tangent theta. Tangent theta. So therefore, our theta, okay, equals arc tangent. Diba? Arc tangent. Arc tangent. Okay? Of 1,800 newtons over. By the way, already cancel this out. Cancel. Cancel. So no more newtons. No more newtons. Over 19,620. Okay. Or in your calculator, what appears in your calculator? Theta is equal to tan negative 1, then 1,800 over 19,620. Okay. Then what is that in your theta? Therefore, is equal to calculator theta 1,800 divided by 19,620 equals, then get the tangent. Okay, tangent. Where's my tangent? Okay. Tan equals. The answer here is 5.24. I will carry all, ha. 181947. Yan na. Or your final answer will be theta is equal to 5.2. This is your final answer to the problem. Okay? So you need a diagram, you make a sketch. I made several diagrams there. Okay? So that's the answer. So problem number 90, I answered that for you. But you have to rewrite that. You still have to solve that. Rewrite it. Okay? Step by step. Okay? Okay. Next problem here, you still have to rewrite that. Your handwriting, ha? You are going to solve it by you. You will solve it for yourself. Okay? Handwriting. Solve. Resolve. So that you can understand. You are going to trace. Similar to mag-trace sa mga contact sa mga COVID positive, tracing ang DOH. So mag-trace po ka sa solusyon, ha? I-trace na ninyo. Yun sa manihan to. You can understand, you can get it. Repeat that, you can get it. Okay? Okay. Then, problem number 91. Okay? What you are going to do here for problem 91, there is that train going up. Okay? Problem. While a train is moving up a track of slope 1:10. Okay. I'm going to erase this one. I'm going to erase no problem if I'm going to erase this one because this is recorded. Okay? I'm going to erase erase, no problem, no problem. I am going to erase here. Okay. Okay. So, a train is moving up. Okay, I will make a diagram for you. There, this one is inclined, something like that. Then, the ratio here, according to this is 1:10. That's the ratio. 1:10. It could be 1 kilometer is to 10 kilometers. This is the angle theta. Okay. Okay? So, what's the unit there? 1 meter or 1 kilometer or 1 mile or 1 foot or 1 inch? Well, certainly it will be in kilometers because that's the track of the train. But with or without the units, you will find out in the solution that the unit does not matter. Okay? Okay. There is the train moving. There is the train moving here. Okay, moving in that direction. And then while moving up at 50 kilometers per hour, the last car of the train suddenly becomes uncoupled. So, remember, the train is composed of segments of cars. So, you have here, 1 car, 2 car, 3 cars, assuming. And this one is being detached. The last car, detached. Detached for whatever reason, naputol or whatever. Detached. There is a mechanical problem, for instance. Okay? Detached. So that detached car will continue to move up. Will continue to move up. By the way, because the first law of motion, a body in motion will continue in motion. But, because of friction, later it will go down. This one moves up, uncoupled, detached, it will continue to move at a certain distance, but it will go back. Because it is a slope, incline, it will go back. But before going back, down, okay, it will still travel a certain distance. And that speed, when it stops, is 0. Upon stopping, momentarily stops. Later, it will move down. When it moves down, the initial speed is 0. When it moves down, because it stops. It stops, then moves down. So, before moving down, initial speed is 0, then going down. But, before that happens, it goes up. It goes up. Slows down until it will stop. So, initial speed going up, 50 kilometers per hour. 50 kilometers per hour going up. But because it is now uncoupled, detached, it will be left behind because it will stop at a later distance. Okay? It will stop at a later distance. And the final speed must be 0. Then at that final speed 0, it goes down. And that final speed becomes an initial speed in going down, which initial speed is 0. Very difficult. Very difficult. Luwi kayo? Let's try. Okay. Here, you are asked here. Okay. So, detach. Here, let me have another one. Another drawing. So, the main body is already here. The main body is already here. 1, 2. The last body, the last car here. Last car here. The uncoupled last car here. Okay? So, this will move and this will stop. Final speed equals 0. Okay? Final speed equals 0. The question here is, what is the deceleration of the car? There is deceleration because while this one moving goes up, bilin, this one slows down. So there is deceleration, negative acceleration. Okay? So negative acceleration until it stops. So we will solve this problem using our previous discussion. Okay? Where's that? I'm looking at the problem here. Friction is 0. Okay? So friction is 0. So because there is a force that pulls, here, and of course you have the normal force. This is the normal force, and the weight is here. This is the weight. The weight is always there. This is the weight. The weight is always perpendicular to the surface of the earth. That's the weight. This is W. It has two components. We have two components. This component, this is W cosine theta. This is our theta. And this one is W, this component is W sine theta. This component here. That component. This component. This component is W cosine theta. Okay. As it goes up, there is no more main body here. This is left behind. There is now a force, okay, pulling the car down. And this force is W sine theta. Okay. That's W sine theta, parallel to the plane. The W sine theta is parallel to the plane. This force is W sine theta. They are parallel, opposite sides of a rectangle, because we can form a rectangle here. You have here a rectangle. Okay, in a rectangle, opposite sides are equal. Okay. Here. Okay. Now, so, let me start here. Before the acceleration, you have the force equals, okay, acting here, equals W sine theta. Assuming there is no friction. Assuming there is no friction. It will continue to go up, but because of this pulling force down, the component of the weight, W sine theta, it will go down. But before going down, it will stop. at a certain height. And this one, according to the second law of motion, MA. F equals MA equals W sine theta. So MA equals W is mg sine theta. Cancel the m. So the acceleration therefore equals j sine theta. Okay? J sine theta. J has a value 9.81 or 9.8. The value of G. Sine theta is equal to, this one is theta. Theta here. Theta, this theta. Theta is equal to, okay? Theta is equal to this one times this one. Sine theta is equal to the opposite side over the hypotenuse. Okay? Opposite side over the hypotenuse. That is how you get sine theta. But we can get theta using tangent. Tangent, without worrying the hypotenuse, because we get the hypotenuse using Pythagorean theorem here. Beside Pythagorean theorem, the hypotenuse is equal to a squared plus b squared. And usually, we have here c squared. And c therefore equals the square root of e squared plus b squared. That is how you get the hypotenuse. Oh. Solve the hypotenuse in order to get sine theta. Sine theta equals the adjacent side over the hypotenuse. To avoid that, shorter one, you get the tangent. Tangent, wait. To avoid this one, using the Pythagorean theorem, avoid this, I'm going to erase this. To get the theta, tangent theta, okay, equals the opposite side over the adjacent side, di ba? Opposite side, our opposite side is 1 over the adjacent side 10. So theta therefore equals tan negative 1 over 10. So what is that? Calculator. So 1 divided by 10 equals then inverse tan equals 5.7. 5.71. Theta equals 5.71. I will just have this 0, 5, 9, 3, 1, 3, 8 degrees. Or we can just have 5.7 degrees. Or 5.71. Or carry all the digits there. It does not matter. But usually in a face-to-face class, in my physics class, I always advise the students, my students, to carry all the digits because these digits have something to signify in some computations. Okay? There will be a lot of board works there. Why carry 2 digits after the decimal point? Why carry 10 digits after decimal point? Why not carry a digit after decimal point? In other words, we are talking on significant figures. But in our online class, if you have this answer, 5.7, it's okay. Okay? So, after getting the theta, the angle theta here, this is equal to theta, you get the sine of that. Okay, you get the sine of 5.7. And then, you have the acceleration. After having the acceleration, because you are asked, what is the acceleration here? The acceleration here is a negative acceleration. Negative, You have to indicate negative because it is slowing down. As it goes up, slowing down. Why? This one is left behind by the mother train. A part of that, the car is uncoupled, detached. So somehow it will stop. Why it will stop? Because of this W sine theta keeps on pulling. The component of gravitational pull from the weights. Okay. So, you have that. Then, you have the answer. You are going to show that the acceleration is a negative acceleration. Okay? Then, next, how far the track will the car roll before it stops? Then what speed? Letter C, there are 3 questions. There is that deceleration. It will travel a distance. From this point here, from this point here, somewhere here, it will travel a distance. This distance. It will travel that distance. The problem is asking, what is this distance traveled before it stops? What is the distance traveled? What is this distance traveled before it stops? So, you are going to use our several equations there. So, you can use our equation. X is equal to b squared minus b sub 0 squared over 2a. You can use that equation. Acceleration is given. It's a negative acceleration. Okay, here it's a negative acceleration. Final speed is 0 because it will stop. Initial speed is 50 kilometers per hour. The 50 kilometers per hour, convert that to meters per second. Okay? It will stop. This is 0 because the question is asking, what is distance covered? What is the distance traveled or covered by the detached car before it stops? So, use this formula. Final speed, it will stop. 0. Initial speed, 50 kilometers per hour. Convert 50 kilometers per hour by meters per second. Okay? Okay. A. Solvable, but you have to show that it's negative. Because that there is deceleration. This car is slowing down until it stops. So, the acceleration is negative. So, this one must be negative. I am already laying down before you the equations, but you have to supply the negative sign. And when are you going to supply it? You are going to show it in your solution. Okay? I'm just giving you the general there. Specific, specific. At least I'm providing you the diagram. You make a better diagram because your diagram certainly is better than mine because you have the ruler. You need the ruler, Use the ruler to make a straight line. Straight. This one is not straight. Oh, it's not straight here. Do it better, Okay. Then the next question is, what speed does the car attain? So speed here, you are going to use this equation also. Here, the reverse is now different. This initial speed, because it will go down. Initial speed is 0 because it will go down. The third question is about going down. Initial speed is 0. Why is 0? Because it stops. And when it stops, it is at rest. Then later, at rest, therefore, initial speed is 0. Then later, it will go down because of W sine theta. Okay? So, you use this equation. Okay? Use this equation. About that. Okay? Then, because you have the distance here. The distance is unknown already. It will travel a distance. Remember, letter B, you get the distance. Letter C, find the speed. So you get the final speed. Initial speed is okay, just review the video. Relax. The next is elevator. Oh, this elevator problem is similar to example number 10. Example number 10. Example number 10, elevator. Example number 10. I'm looking at example number 10. This one, similar. Example number 10, also about the elevator. Example number 10, also about the elevator. So you just follow how this one is solved. Okay? The next 93 and 94, you analyze this 93 and 94, and then before the deadline, when is the deadline of this one? I will be explaining 93 and 94. Okay? Okay? So do your best. Do your best. Just relax. At least I'm guiding you. Do it. Rewrite the equation. Okay? Right.